My name is Rob Winch. I'm the project lead for Spring Security. Welcome to the state of securing RESTful APIs in Spring. Today we're going to be talking about very in-depth authentication with REST. So how do I authenticate? And the reason why we're going to spend some time on this is because I find that a lot of people believe there's a mismatch between security and REST when it comes to authentication. So I think if we dig into things, we'll find that there really is no mismatch. And then we're going to spend some time doing authorization. And we'll end with a few exploits at the very end. And we're going to have some time for Q&A. But speaking of Q&A, if you have a question, the best time to ask it is when you have it. So if you have a question, please raise your hand, and we'll try to answer your question as we go. Of course, there'll be time at the end as well. And if you don't like asking questions in public, you can come up afterwards and talk to me. Or if you see me around the conference, feel free to ask questions or just say hi. All of them are fine. One thing I will say is today's talk is largely theoretical. So this is going to be why we're doing certain things. I'm giving a talk tomorrow, which I'll have at the end of the slides, that's hands-on. It's going to be more about how we do stuff. So we'll apply security to the application that we're talking about today. And we'll see how to do that. And we'll also see some live white hat hacking. And there'll be the potential for audience participation in tomorrow's talk for the white hat hacking. So if you want to participate, it's a lot easier with a laptop versus a mobile device. So if you're coming tomorrow, keep that in mind. You won't miss out on anything, really, if you don't want to do it with us. But it could be fun. All right. Moving on, as soon as I turn on my thing. All right, so before we get too far along, I need to give you a little bit of a warning. And the warning is, as someone who's interested in security, I'm going to be telling you what I think you need to hear, not necessarily what you want to hear. And if you hear something that all of a sudden you say, oh my gosh, this guy doesn't know what he's doing, get off the stage. I expect some of you will think that today, but I want you guys to take a minute and put things into perspective and think about it. Don't just react, think. And I'm saying this because a lot of times I find that security is kind of an afterthought, you know? And it happens for various reasons. You know, some people say, well, users don't really care about security. They just want features. I got to get these features out. I also hear people saying that, well, I'm just going to get a slap on the wrist if, or you know, a $200 fine if something goes wrong. No big deal. But the reality is while users don't care about security when things are working well, as soon as it falls apart, you better believe they care about security, and you'll hear about it. And if your app is of anything importance, the press is going to let you hear about it too. And at that point, you'll start to realize that security is very important. Security is very directly tied to trust. And without trust, you can't have any sort of relationship. You can't have a relationship with a friend, an application, or a company. And you might find that your customers believe the same thing, and they start leaving your company. So it might very well be the death of your application or your company if you betray their trust. So as we're going through this talk, again, if you hear something that you disagree with, think about it. Put it in perspective. Think for yourself. You can't trust anyone blindly. You got to think for yourself. Well, you can trust me blindly, especially today. But everyone else, you must think for yourself. All right, the disclaimer's out of the way. What is authentication? Authentication is describing the who. Who's trying to access a particular resource? And you can do this in a lot of different ways, but the most common way that we're familiar with is using a username and password. And a username and password is secure, presumably, because when you chose that username and password, you randomly generated the password, and it was plenty long with a lot of entropy. And you rotate that password frequently, and you also don't reuse your username and password anywhere. And you follow all sorts of other nice security recommendations. Yeah, passwords sound great, don't they? but they are one of the best things that we have for authentication. There's other ways to authenticate that you can layer on top of that. Single-use tokens, right? So all of these are valid ways. So how do we use this in a typical web browser? In a web browser, you might visit mybank.com, and you type in your username and password, and then you don't have to request the username and password again. It doesn't have to ask for every resource. And that's great, because it would be totally unusable if you had to type your username and password every time. So what happens is when you submit it, the server responds back with a session, and that session is presumably secure because it uses a secure random generator with plenty of entropy, and it attaches a finite lifespan to that session. So that gives you a little bit of value because not very many people are rotating their passwords all the time. So that session gives a little bit of additional value to you. Now, the question is how should I submit that session? Is a session valid for REST? And the answer is, well, it depends. There is no one-size-fits-all solution, of course, but we're going to go through some of the scenarios here. So in a web browser, it's a great idea to use a cookie, even if it's a single-page application. Why do I say that? The reason is because you have defense in depth, right? The cookie can be marked as HTTP only, and then the JavaScript cannot access it. So if you have a cross-site scripting vulnerability, you're basically limiting your liability, right? So in a browser, a cookie makes perfect sense. But what about outside of the browser? Outside of the browser, it doesn't make a whole lot of sense, particularly if you're running lots of users through the same client, because it's hard to keep track of which user is which. Cookies are automatically persisted by most clients because that's the specification. And so it doesn't make a whole lot of sense to use cookies for a mobile application, for example. So how can I authenticate with a REST client that's not in a browser? Well, here's a naive approach. And other than my password being incredibly difficult to remember, what is wrong with this? I think I hear quite a few people saying the password's in the URI. And that's correct. That is not good, even though it's over HTTPS. So while the query parameters are encrypted, they can be leaked in many different ways. So for example, it could be leaked inside of a browser history. It could be leaked inside of proxy server logs. There's all sorts of ways that that information can be lost. A refer URL, correct. Yeah, there's plenty of reasons. So what should we do instead? Well, actually, before that, this brings up another very good question. What about other sensitive information? Let's say I have a user API, and I need to look up that user by their social security number. Or I'm finding someone by any sort of sensitive data. Should that be a get? I'm getting the resource. I know I'm starting to rub nerves. It's not RESTful. Oh, man. OK, so yeah, you shouldn't use a get for that either. Instead, you should use a post. I know. Get off the stage. We're out of here. You're laughing because I'm right. So again, you need to put this into perspective. Let's say you lost someone's social security number, or a whole bunch of people's social security numbers, and they come up to you and say, "Hey, so what happened? I'm just trying to understand." And you're like, "Yeah, well, we had to be RESTful, so HTTP GET is in the logs. You win some, you lose some." And they're going to be like, "Oh yeah, REST, duh, yeah, GET." No, they're going to be like, "Yeah, my lawyer is going to be contacting you," right? Put it into perspective. What do you want to do? Do you want to be secure, or do you want to follow these things blindly? Now, this actually reminds me of a very awesome cartoon. Well, I'm kind of a geek, but hopefully some of you guys are too. And anyone here used to or still watch Futurama? Anyone? OK, there's a few hands. So Futurama, there's a guy named Fry. He's not the brightest guy, but we're going to take some of his advice today. I know, another reason for me to get off the stage, right? But so Fry says to his best friend, Bender, Bender's a robot, and he says, "Bender, if someone programmed you to jump off of a bridge, would you do it?" And Bender says, "Let me check my program." "Yep." And Fry responds with something rather intelligent, especially for Fry. He says, come on, Bender, it's up to you to make your own decisions in life. That's what separates people and robots from animals and animal robots. So I urge you, don't be an animal robot. Think for yourself. Again, I know it sounds like you don't want to do this, but think for yourself. Now, this whole time you're saying, okay, you're telling me to take advice from Fry. Yeah, but we do have reasons to back this up. I gave some of them out there, but there's also the HTTP specification actually outlines this very explicitly. Do not use GET for sensitive information. It goes on to say, don't do this because the information can be lost in many different ways. And instead, you should use a post. Now, the other place you can put the information is in a header. So a header is also acceptable, or the body of the request. So with all that in mind, let's see how we might be able to authenticate. Most basic form of authentication, pause for no laughter, is HTTP basic authentication. And so if I make a request to a resource and I'm not authenticated, then I'm going to get a response like this. And it's pretty simple. I'm going to have to respond with a request that looks like this. Now, what's wrong with that? Well, the username and password is base64 encoded, and it's very easy to undo. So if I were doing a man-in-the-middle attack, I could undo that. Now, I know some of you are thinking, well, what about HTTPS? We'll get there, but some people might be going down a different trajectory, so we're going to explore that very briefly. Digest authentication. The idea of digest authentication is I'm not going to have to submit the actual password over the wire, so it's going to make it more secure for me. But let's explore what happens. This is what your response looks like when you make a request to a protected resource. And we don't need to know all the details about this. We'll get to the punchline in just a minute. And here's the response, or the request that you have to produce. Now, it doesn't really matter what all that is, except for right here we have MD5. MD5, what? MD5 is terribly broken. And if you want any sort of certification, yeah, that's not going to happen. What's more is your password can't be stored properly, right? Because in order to calculate this, I need the MD5 hash of the username, the realm, and the password. So I either need to store the password in plain text, or I need to store the MD5 hash of the username, realm, and then password. And MD5 is terribly broken, so you can't do that either. So this is really a no-go. So if we can't use digest authentication, what about revisiting our previous idea? HTTPS. So just a little bit of clarity for those that aren't quite sure of the subtle details. SSL is the older version of TLS. TLS is the newer version of SSL. When it's combined with HTTP, you get HTTPS. So a lot of people use those terms interchangeably. We're going to be talking about TLS, but you can somewhat translate those. So TLS, what does that provide me? What is it going to give me? Well, it's going to give me at least two important things: confidentiality and integrity. So what do I mean by confidentiality? I mean that it's a secret. So when I type in my username and password, no one else can see that username and password. And when the server provides a response with my bank information, no one else can see my bank account. These are very important, but so is integrity. Let's consider the following. Let's say that when I submit a request to the server, I say, transfer funds from my savings to my checking. You don't want anyone to be able to modify that request and say, oh, transfer from his savings into my checking. Right? So they're different things. He might not have been able to read the request, but you don't want him to modify it either. So they're quite a bit different. And at this point, I oftentimes hear people say, well, do I need to do HTTPS everywhere? Yes, thank you. Woo! And a lot of people are like, yeah, I know what he's going to say. But thank you for also saying that. Appreciate it. Yes, you do want HTTPS everywhere. And at that point, I hear, HTTPS, it doesn't perform, sad face. Yeah, and then I say, well, have you got any numbers on that? I'd like to see your numbers. And then they say, well, no, it's just slow. And I say, oh, yeah, I guess it's, yeah, well. And they're like, see, what about this static resource I have? So here's my scenario. I have this JavaScript file. It's actually jQuery. And you can download it off the internet anywhere, right? So I could download it off the internet anywhere, so who cares if anyone sees what jQuery is? And I said, well, yeah, no one cares about it, but let's consider the following scenario. Let's say you go to a coffee shop, and you get onto the Wi-Fi, but you think it's the Wi-Fi, but it's actually me in the corner because I like to be evil, and it's my network, and I am doing a man-in-the-middle attack. So you get onto there, and you go onto mybank.com. It's over HTTP, and it serves up jQuery. And of course, everyone knows what jQuery looks like, but no one verifies what it's going to be when they download it. So when you get it, I actually serve you up a version of jQuery that has some malicious code in it. It's code. Well, JavaScript arguably is a programming language. Can't believe I just said that with a straight face, but yeah, I know I get discredited as a security guy saying that. But I mean, you could do a lot of things with JavaScript, right? You can. You can manipulate the DOM. You can do all sorts of stuff. I mean, it's basically everything that you need to do. So whenever I send you that JavaScript, I'm going to do whatever I darn well please with your browser. And what am I going to do? Well, there's lots of things I could do. If there's a login link, I could change that login link to point to a form that submits to my server. You're like, well, it'd probably switch over to HTTPS at that point. OK, fair enough. But what if the link where I change the link from mybank.com, and instead of going to HTTPS mybank.com, I sent it to mybank.securelogin.com, and it was over HTTPS. And it was branded to look just like that site. And in fact, it was HTTPS with a valid certificate. But what do you know? I own securelogin.com. How many people, maybe not engineers, but I bet a lot of people would enter their credentials, because how are you to know if they aren't using a third party for authentication? It's a very common practice these days. So, and even going back to the HTTP example, a lot of people, if you put like a nice 100% secure and a lock icon and stuff, a lot of people will probably enter their credentials too. So you might not even need the HTTPS example. But the point is that it's very important to protect all your resources, including your static ones. So what about CSS? CSS is very similar. I can manipulate the DOM in the same way. I can hide elements. I can insert elements before elements. CSS is also important. How about static HTML pages? Well, of course, I can do all the same things. I can embed JavaScript. I can change the DOM. All of this is very important. So without having a trust at the beginning, how do they know that they've gotten to the place that they need to go? You need trust everywhere. And you don't need just confidentiality. You also need integrity. So HTTPS everywhere. So at this point, a lot of people are saying, yeah, HTTPS, fail. OpenSSL. So for those that don't know, these are logos. They like to have lots of logos for vulnerabilities anymore. And it's actually somewhat dated. There's more out there these days. But the point is there are vulnerabilities with HTTPS, and they get fixed, and we move on. And it is the best we have. So we need to do our best to protect our users. So when they come to us, we could say, hey, we did our best with the technologies that we have. And it is hard to get our HTTPS setup correct. So how do we do that? Well, we aren't going to go over that in detail today, because we don't have time. But I'm going to provide you some a couple links. And I see you all going cross-eyed trying to get that domain right. Don't even try. We're going to have a link to the slides, and you can click on it, because I don't need anyone passing out trying to focus on that. So we'll have a link to the slides at the very end, and you can copy those links, and they'll help you make sure your sites are secure. So at this point, we need to revisit the question that we had earlier about performance, because admittedly, performance is very important for our application. So HTTPS and performance, what are we going to do? Well, in order to understand performance, we need to understand what is happening with HTTPS. And the main concerns that you have are latency and computational overhead. And when does that happen? Well, it happens in the handshake. Why does it happen in the handshake? Well, in summary, the handshake of HTTPS does asymmetric cryptography, and that doesn't perform as well. But once you switch over to, once you finish the handshake, you switch over to symmetric. And at that point, you're going to flood your NIC before you are bound by CPU, and it's not going to be an issue. And some of you are like, okay, well, that's great, but where are your numbers? And I'll tell you, well, I'm not that smart either, and I didn't get any numbers. But fortunately, some other people have. So here's a quote from Google. And Google has switched over to HTTPS, and they said that only 1% of their CPU load, which is one of the things that we were concerned about, is accounted for by using HTTPS. 1%, pretty negligible. What about someone else that might know what they're doing? Facebook. Facebook says, we're not using we're not using special hardware, we're using commodity hardware, and still everything is just behaving fine. So you don't have to buy anything special if you're worried about your budgets. And then finally, Twitter. Twitter also says that because we're using keep alives and resumption, we are doing just fine as well in terms of HTTPS performance. Now, a lot of times at this point, people say, well, that's Twitter, Facebook, and Google. And I say, okay, well, they're probably getting quite a bit of traffic. You need to put it into perspective again. So they have lots of resources, they have lots of know-how, but when you put it into perspective for your organization, if you have the same number of requests that they have, most likely you have the same sort of support they do. If you're a smaller organization, then it's probably relative to the amount of traffic that you're getting. So this is very doable even if you're not a Facebook, Google, or Twitter. It is very doable. And you might say, well, how might I do that? How might I do that? Well, here's a very brief bullet list of some of the things that you might do. And we aren't going to actually talk about these in any detail because, again, we don't want to spend a lot of time on this, but we want to talk about why HTTPS is important because that's a fundamental thing. And I want to provide you with a resource, is tlsfastyet.com. Obviously, there's no spaces in the domain, but it made it a lot easier for you to read. So is tlsfastyet.com. And this should make things a little bit, basically tell you how to optimize your site. So now, what about our original question? What about HTTP basic over HTTPS? Because we want to be stateless. In order to answer this question, we have to take a little trip through time. Back when I was a kid, or even maybe before I was a kid, plain text was known to be fine, or thought to be fine. You could store passwords in plain text and no one would flinch. And then we started having people doing things like SQL injection attacks and dumping the database, and they'd discover all the username and passwords. And what we found is that everyone reused their password, their username. And so people could log into another site using that information. And so we realized that we had to do a better job of protecting our users. So we moved on to MD5. And how did it work back then? Well, the idea was that when I stored the password, I'd store the MD5 hash of the password. When someone entered their password, they would calculate the MD5 hash of what they entered and compare against what was stored in the database. And if they were equal, then they were authenticated. But as we discussed earlier, MD5 is terribly broken. So moving on, a little bit later in time, we discovered that SHA was a great idea. And SHA is a cryptographic hash that allows me to do very similar things to MD5, but it is less prone to having collisions. And so it made it a little more secure, and it was a little slower as well, which was good, because you couldn't crack it as fast. So that was nice, because because then people couldn't crack the passwords as easily. But we discovered that while attacking a single user was painful, you could attack all the users at once. So instead of cracking each individual password, basically run through all the passwords and store them in a lookup table. And then if I found a hash, I'd just say, what is the original password? And these were called rainbow tables. And so we decided that was a bad idea as well, and we moved on to using salt with it. So what is salt? Salt is a randomly generated set of bytes that is put before or after the password and then sent through the hash. And before or after is a little debatable. Some people try to argue one way or the other. The point is that they combine the salt with the password, send it through the hash, store the original salt or random bytes along with the hash. Then when someone tried to authenticate, they would type in their username and password. The password would be combined with the salt that was previously generated, run through the hash, and compare the two hashes. If they were the same, they were equal. Well, I got news for you. That also is broken. So let's take a look at a little bit of a demo here. So has anyone stayed up on the news with, heard about the Ashley Madison hacking? Anyone heard about that? So right here, I'm running a program against the top 25 passwords from the Ashley Madison website. And I did have to clear out the dirty ones because there were quite a few. For those that don't know, Ashley Madison was a site for cheating on your spouse or significant other. So you can imagine there were some nice passwords in there that should not be on screen. So I cleaned them up, and the ones that were left, I'm running through a program called Hashcat. Has anyone heard of Hashcat? Decent? Pretty decent. Okay, number of hands. So a Hashcat is one of the fastest open source ways of cracking passwords. And so what we're doing is we're running against the SHA-256 hash with salt of all those passwords. And you can see that it's actually, it looks like the line wrapping is fabulous on this. You can't see the passwords. We'll cat the file at the very end to see the result. But what am I running it against? Well, I'm using Hashcat, and Hashcat is using a dictionary attack. And a dictionary is loosely defined because it's not actually regular words that you might see in a dictionary. These are actually the collection of passwords that have been deciphered from previous dumps. So it's a whole bunch of passwords that includes, if you're doing leet speak or whatever you're doing, tacking a 1 onto the end, doing all sorts of random, all those passwords are in there. If you're using non-ASCII stuff, if it's been found in a password, it's in this dictionary called Hashkiller. So I'm running Hashkiller against there, and you can see it's actually already completed. And I'm going to go ahead and empty out the results here. So actually, this resolution is fabulous for my case here, but the first part is actually the hash, and let's see if we can do. So we'll just scroll over here. The resolution is really helping me out here. And apparently it still won't work. There we go. So yeah, it's okay. Just bear with me. You can see at the end of some of these, it's still kind of line wrapping. But 1, 2, 3, 4, 5 is one of the most popular passwords. Very secure, right? Chris, Camaro, Dragon, Ginger, and Help Me. So these are the top passwords. Yeah, I know. Some of them are questionable if I should have cleaned them up, right? But ginger is just a type of drink, right? So the thing is, these are the top passwords, and we cracked them very quickly, right? Arguably, but I will say that actually wasn't even really all that quick. And you say, well, I thought it was pretty quick, and the reality is, it could be much quicker because I was running on a VM. So this is a Mac, and I was actually SSH'd into a Linux machine, Linux VM. because Hashcat doesn't run on OS X, at least very easily. And the other thing is, we were using a CPU to crack them. No one's going to use a CPU to crack your passwords. They're going to use a GPU. So what sort of numbers can you expect if someone's actually trying to crack your passwords? OK, here's a number for you. SHA-1, 42.4 billion hashes per second. And this is on a single GPU. That's a lot of hashes. How about if we up the ante a little bit? SHA-512, 5.2 billion hashes per second. Is SHA safe? Do we want to store our passwords that way?
No.
Yes, thank you. And by yes, I mean he's right. No, you don't. No confusion. So what's wrong with this situation? The problem is it's way too fast to crack these passwords now. We have evolved. The problem is we're using a cryptographic hash to store our passwords, and we shouldn't. Cryptographic hashes are meant to be fast. They're done on the fly. They're meant for networking, right? Instead, we should use a password-based hash. And a password-based hash is intended to be slow. It should be slow, and it should be adaptive. We should be able to change it as our resources get better. And to do this, we would use an adaptive one-way function. And you might say, well, what one should I use? Well, there's a few out there. PBKDF2 is one. bcrypt, script, or scrypt, depending on how you want to pronounce it. Heard it said both ways. You might say, well, which one do I want to use? And the answer is, always, it depends. If you need certain types of certification, you might need to do PBKDF2. If you have your choice, and you or me, I would use bcrypt. And scrypt is nice. In my opinion, it's a little too new still in terms of, from a security standpoint, things need to be fairly old for people to feel like they're secure, and people to still agree they're secure after that amount of time. So the answer to that is it depends. Now, we said they were adaptive. How do we tune these? What are we supposed to do to make it secure? Well, the general consensus that I've seen in the industry is you should tune it to be about 0.5 seconds for your hardware, so about a half a second. And obviously, it'll vary if you switch hardware and stuff like that. And obviously, your hackers may have better hardware, but the general consensus is for your hardware, a half a second. And you might say, well, why would I do that? Well, here's the reason. That Ashley Madison website, the one that we were talking about earlier, had 25 million passwords. That's a lot of passwords. And only 4,000 of them were cracked when running a dictionary of 10,000 against it. And the guy that did the research on these passwords said that it would take over 100,000 years to crack all the passwords with the current hardware that we have. And why is that? It's because they use bcrypt, right? So that gives you an idea. It's basically the hardware that he was using, which was intended for this sort of thing. I can't remember the exact number, but it was something like between 100 and 200 hashes per second. Compare that to the billions that we see up here. So this is why you want to use proper hashing, because it can really protect your users. Now, Ashley Madison had their own problems with their security, obviously, because they had a dump, but they also didn't store their security questions properly. So there were plenty of other things, but they did do password storage properly. And we can learn from that. So what does this have to do with our question that we asked so long ago? HTTP basic over HTTPS. Well, I guess we could do username password on every request and validate it. But at that point, if we're tuning things correctly, it's going to be at least a half a second for every request. And then we have to do everything else. Is that acceptable? Well, maybe for some, but I have a little higher standard than that. I think that we need to do a little better. So what can we do? Well, if something doesn't perform, what do? We cache it, right? We cache it. So what can we do? We can introduce a session. And I know you guys are saying, oh man, this guy is really doing a number on me. He's session, state, that's terrible. We won't introduce any state. We're going to encode it in a token. So here's our token format. And our token needs to be secured. So we're going to go ahead and encrypt it. And that might be a little hard to see in the back. Can you guys see that in the back? Oh, good, you can. So we're using AES-CBC, which is a NIST-compliant encryption algorithm, so that's perfectly fine. We're using a random initialization vector, just as recommended. And we're going to keep the key a secret only on the server, so only it can read it. Yet something is terribly wrong with this situation. And while you're pondering that, pop that up there for just a little bit of a hint. For those that you don't know, this is me before I got into security. I thought that my handwriting being really bad meant the teacher couldn't figure out what it said. I thought it was encrypted. And this is a big hint to what was wrong, right? What is wrong with our situation? Well, earlier we said there's integrity, and there's also keeping things a secret. Encryption keeps secrets. It doesn't prevent you from changing it. So the authenticity is not there. We encrypted it, but did not protect it from being changed. You might say, well, if it's encrypted, how are you going to change it? Well, we won't get into the details of how to do that, but just to put it in perspective, if I have the encrypted token above, say I log in as myself, I can modify it to be the encrypted token that is below. So I can switch the username to be admin. So this is not a secure scheme, and you might say, well, please do tell me how. We aren't going to have time to cover that. Throwing you guys little nuggets if you want to continue down a path. So if you want to learn more, the link in the slide that says change right there, you can follow that link and it'll take you to a GitHub repository that has a README in it that explains exactly how to go about doing it, and it provides a sample code of changing exactly the first token to the second token. And I know what a lot of you may be thinking. All right, you've made your point. We aren't smart enough to do cryptography ourselves, so that's why we have standards, right? Why not use a standard? How about JWT? And this is my response. And you might say, well, who's this guy? Does anyone know who this is? Well, Tony's not here, so I'll answer for him. He is a cybersecurity engineer for Square Engineering. He's a very well-known and respected guy. He knows what he's talking about. So now you're saying, well, why wouldn't I do that? Also, actually, I should add this in. Does everyone know what JWT is? Josie? Okay, most people? Good number at least. So very quickly, it's a way of representing tokens using JSON and keeping them secure. So you can encrypt the tokens, you can sign the tokens. It's a way of representing tokens in a stateless manner using JSON. And it's a standard. You might say, well, is this guy a lone wolf? Well, I'm guessing you know my opinion on it since there's a slide up here, but let's see. This is another very prominent guy. Now, remember what I said about thinking for yourself. Don't actually punch yourself in the face if you actually thought about doing this. So think for yourself. Don't punch yourself in the face. I don't need sued. But you should at least be doubting using this approach at this point. And now you're saying, okay, well, get to the punchline. Why shouldn't I do this? What's wrong with this approach? Well, the fundamental problem with JWT is that you're doing something before you validate the token. So let's take the steps to validate a token. First, you have a JWT header, and it looks something like this. And in it, there's an algorithm. And the algorithm, in this case, is HMAC-SHA 256. So what you do is you take the algorithm out of there, and you validate the signature on the token according to that algorithm. That sounds fine. And the specification says read the algorithm, take it out, validate the signature according to what the algorithm is, and move on. But the problem is there's also an algorithm called none. So consider an attacker that submits a token, and he doesn't know the key, but he knows there's an algorithm called none. And he basically doesn't sign it and specifies the header as none, and he creates whatever tokens he wants. And you might say, well, that's way too obvious. No one's going to fall for that. Ha! Think again. They did an analysis on lots of the open source libraries that implemented this. I'd say over 50% of the ones listed on the specification as reference implementations did this. Okay, that was obvious. I would have caught it. You might be saying that. That was obvious. But what about this scenario? There's also a RSA algorithm. So what's wrong with that? Okay, let's consider the following situation. So first of all, RSA is an asymmetric mechanism for cryptography, and HMAC SHA-256 is symmetric. So what does that mean? Symmetric means you use the same key for creating a signature and verifying the signature, whereas RSA is going to use a private key to produce a signature and a public key to verify the signature. And the public key is known to everyone. That's why it's called the public key. And that's nice because anyone can verify the signature. So let's consider the following situation. A client has set up their app to use RSA, and they say, or I guess a service has set it up to use RSA. And so when they're verifying it, they're going to verify using the public key, right? So they use that public key and they verify the signature on their end, and that's fine. But what if the attacker sent in the algorithm as HMAC SHA-256? What would happen then? So what he'd do is the attacker would say, okay, I'm going to create a token, and the public key is known to everyone, so I'll use that public key and I'll actually sign it with HMAC SHA-256, and then tell the service to validate it as HMAC SHA-256. So it looks at the algorithm following the specification, grabs the algorithm, and then grabs the key, turns it into a valid signature, and everything works. And you might say, well, can you do that? Can you actually use an public key for HMAC SHA-256? Yeah, you can. It's just bytes. There's another known exploit that happened against it. You might, okay, well, everything gets its known exploits, but the fundamental problem here is you're doing something before you're doing your cryptographic verification. And that's a problem. They even have modified the specification to say, we think we're going to deprecate the algorithm. But there's still some other issues with JWT. So some of it's all the if logic in the verification process is rather complicated and difficult to get right. One of my favorite quotes from the specification is, when decrypting, particular care must be taken not to allow the JWE recipient to be used as an oracle for decrypting messages. What? So there's a whole specification on how to not have that happen. That's only one little, almost unseen line within the specification, within the warnings. So the point really is, cryptography is hard even for the experts. We saw that with all the bugs in OpenSSL as well. These guys are experts, and they have trouble with it. And there's a reason for that. It's hard. It's not because they don't know what they're doing. It's because it's hard. So if you can avoid if you can avoid cryptography, you should. Now, I know what you guys are thinking. If we introduce state, it's not RESTful. Yeah, this guy does need to get off the stage. It won't scale. If I have state, it's not going to scale. What if I told you your application already has state? No, it doesn't. So, you're using HTTP. It's a stateless protocol. It's layered on top of TCP. TCP is stateful. you're using HTTPS, I hope. HTTPS is stateful. There's plenty of examples of how stateless and stateful are combined, even in the protocol layers. And you say, well, that's not my application. Well, it's debunking the myth that you can't scale and be fast if you have state, first of all. And second of all, you might say, well, I don't really care. I'm not having state in my application because it should be stateless, and it needs to perform. So I found this no-name guy on the internet. Some of you may have heard of him. And he says that the important thing is that you can't store context on the server. And you almost have to read between the lines a little bit. But I think Wikipedia says it very well. Wikipedia says that you can transfer the state from the server to another service, like a database, right? And you think about that, you do that all the time. I mean, that's what you do with all your data. And it makes a lot of sense, right? It's in the name itself, representational state transfer. I know I'm rubbing some people the wrong way, but it's okay. So let's think about this just for a second. A lot of people are like, well, it's not going to scale. You know, they've heard it so much, it's hard to fight that feeling. Let's consider a scenario. Let's say you have a person service, and that person service is being used a lot, lots and lots of reads, and it's not performing. So your coworker comes up to you and he says, hey, I have this great idea. We're going to make this perform. The identifier is opaque to the client, right? So we're going to take the identifier of the person, and we're going to embed the first and last name into it, and then we're going to embed the gender, and we're going to embed their address, and we're going to embed all the information in this token. And then when they submit the token, the identifier over to us, rather than looking up the user or person or whatever domain object that's going slow, whenever they send it over, we'll just decode the ID, and we don't even have to hit the database. Brilliant, right? Why would you do this with your security if you're not going to do it with your other domain objects? And don't call my bluff and actually do that, because that's a terrible idea. But why would you do that? It's a bad idea. You already have state for the rest of your application. You're just transferring it. If the client had all the state, it wouldn't make any requests to the server in the first place, right? There is state. It's just getting transferred. So at the same time, we've had a little bit of a rocky history. I got to thank Josh Long for this picture, by the way. Didn't realize he was going to use it in the keynote, so now I feel like I stole it. And I did. I admit it, I stole it. So why does it have a bit of a rocky past? Well, HTTP session has a rocky past because the way that we used it. How did we use it in the past? Well, first of all, the default implementation is in memory. And people like to put lots of stuff in the session. They put all sorts of stuff in there. And it got bloated, and it crushed our servers, right? So the problem was not necessarily that people used session, but it was how they used it. It's the same thing with anything in your application. You can kill the performance of your app if you do anything incorrectly. It doesn't mean totally abandon it. It means that you need to figure out how to use it correctly. So what do we need to do if we want to have scalable sessions? Well, for one, it should be rather lightweight, right? Because we're reading it a lot. If you're doing a lot of writing to it, you can't optimize for a read. Not very readily, at least. So typically, your session should be lightweight and almost all read. And at that point, you can get it to scale by putting it on something like an OSQL server like Redis or something. And fortunately for us, HTTP session is an interface. So we can swap out the implementation. In fact, application servers provide this mechanism for you. Some of them provide a way to do it to JDBC. Others provide NoSQL implementations. But there's still some fundamental problems with this for our REST service. We don't want our request to look something like this. And why not? Well, first of all, it's got JSession ID. Do we want that part of our contract? No. Do we want to use a cookie for our mobile devices? No, because it'll be easy to get confused with other requests. Yes, we can modify in semi-newer versions of the servlet container the cookie name, but we still have that problem of being a cookie. So how can we solve that? We can solve that using Spring Session. Hey, we got to some code, right? So Spring Session, what does Spring Session provide me? Well, this code right here is going to configure a servlet filter that will replace the implementation of HTTP session for me. And it doesn't matter which application server it's on either. So you don't have application server specific code or configuration. And you can actually customize the way that you access the session. It has a pluggable API. So out of the box, it provides a mechanism for looking at it up out of a cookie or out of a header. So you can very easily look it up in either mechanism. And it provides an implementation for Redis. And it also provides an implementation for a map. You might say, well, what good is a map? Well, there's a lot of distributed map implementations out there, like Hazelcast. So you can plug in any distributed map implementation, and then you can use that as your backing. But it creates this filter, but how do I plug that into the servlet container? Here's the Java config way. If you're using Spring Boot, who here is using Spring Boot? Awesome. Who here likes Spring Boot? Who here is using Spring Boot and is going to stop using it? I'm not really raising my hand. Okay, good. Yeah, Spring Boot is awesome. So if you're using Spring Boot, it's automatically included. The filter's automatically added. You don't have to do anything. But this is if you're using a servlet container and you need to programmatically add it. And if you need to do it with a web XML, because you're stuck in that world, then you can do it this way. And what is this actually doing? Well, has anyone used the delegating filter proxy? I assume most of you have, since you raised your hand earlier about the Spring Security. So delegating filter proxy, you may not have looked into it, what it's doing, because maybe it just does its job that well, but delegating filter proxy doesn't really do much of anything. It says, what I'm going to do is I'm going to look for a Spring bean by the name of, in this instance, Spring Session Repository Filter, so the name of the filter. You can customize that, but by default, it's the filter name. So I'm going to look for a bean by that name, and I'm not going to do anything when doFilter is invoked, except for look up that bean that is a type of filter and invoke its doFilter method. So that's all it's really doing, is saying, I'm going to delegate all my work to this Spring bean that is of type filter and tell it to do everything. And that's just a way to bridge the servlet container into Spring-defined beans. All right, so that's pretty cool, but let's go ahead and take a look at a brief demo here. And there we go. So here's my sample application, and we'll be talking about this a little more later on. And it's really awesome UI. I know you guys are very impressed. No autographs, please. So we have this application, and we're going to go ahead and log in. Now, when I log in this instance, you can ignore the console. We can cover that a little bit later. But the thing that I want to, I say a little bit later, I should actually clarify, I mean tomorrow in the next session. The main thing I want you to see here is it's using a cookie for authentication. So as we said before, in a browser, it's a good idea to keep things separate. So Spring Session allows you to easily do that, and we're using session as the cookie name. You can name it whatever you want. The default is session because it is felt that that is not going to leak implementation details as very easily. It's one of the OAuth top 10 is leaking implementation details. It's hard not to do it somewhat, but you can do your best to prevent that. But the other thing that we can do is we can actually log in with a REST client. So here, I'm going to just use HTTP client. So anyone use HTTP? It's like curl, but awesome. So what we're going to do is we're going to do HTTP, and we'll do JSON. We'll do auth rob at And so at this point, I should get back a response. It's a lot of response. I probably should have, we're going to do that one more time, but that way it's not quite as long. And now you'll see in the response that when I authenticate, I get this XAuth token in the headers. So hopefully you guys can see that now at the top. So when I'm doing it with, it's using content negotiation. So when I pass in the JSON request, it's going to actually use the headers. So now if I copy this, and I could do X, well, let's actually first we should remove our authentication here. So now when I request it, I'm doing the formatting on this wrong. I think it might need to go before the URL. HTTP, I always, oh, that might have been why, actually. The auth is still there. You guys were probably back there. I see it. I'm not going to tell you, though. And it's still doing it. I think I had it right with, so there we go. Syntax errors, sorry about that, folks. So you can see I get it back. Now, if I don't provide the right token, say I delete one of the values, you can see I'm getting basic auth, right? So you can tell that this actually is working. So I can do it in the headers, or I can do it in a cookie within the same application. Now, would you really want to do that within a production app? Probably you'd want to put your REST endpoint separate from your UI, so it's probable that you wouldn't do it that way. If you want to create a very simple demo app, then you might combine them. So just calling that out. But there may be reasons to do it that way. It's not necessarily a bad thing. It's a depends on your situation type of thing. So that concludes our little demonstration with Spring Session. But how is that working? So I think it's a little easier to visualize when you see the code. Earlier we mentioned HTTP session is an interface, so we can swap out the implementation. But how do we make it transparent for the rest of the application? Because when I add Spring Session, if I'm using HTTP session, no one has to change a line of code. And why is that? Well, we're using a servlet filter, and the servlet filter has access to what's known as a filter chain. In the filter chain, you pass in a request and a response. Now, if I passed in null values into that request for the parameters instead of request response, you get a whole bunch of null pointers exceptions because whatever you pass into the filter chain is what's used by the rest of the application. That's how it knows what to use for your servlet, for your Spring MVC, for the filters that are after that filter. So everything else is going to use that request response. Well, that's great. So what can I do? Well, servlet request or HTTP servlet request, either, are also interfaces. That means I can override those. So how do I get the HTTP session? I call HTTP servlet request.getSession. So if I wrap the request, so I'm wrapping it so that I can invoke all the other methods on HTTP servlet request. I just want to invoke them regularly. But I'll customize one method on it. And how will I do that? Well, I'm going to just override that one method. And I'll provide it with a way of returning a custom session that is backed by, in this instance, Redis. And that's nice because this is following the servlet specification. I don't have to do anything custom, as mentioned before, if I switch containers. It works very well in Spring Boot apps for any of you that raised your hand, or hopefully will be raising your hand soon if you haven't already. So it works very well with Spring Boot. And if you don't like the implementations that are provided, you can always provide your own implementation of Session Repository, which has very basic CRUD operations for a session on it. So it's very easy to implement yourself. All right, so that's nice about Spring Session, but a lot of you may be thinking, Well, we've gone a really long way, and we're talking about REST. What about OAuth? What about OAuth? Well, I do have one slide on OAuth. OAuth has been covered quite a bit, so we aren't going to dive into OAuth. But I think there's a time and place for everything. So when does OAuth make sense? Well, if you remember the analogy for OAuth, OAuth is about giving a valet key, right? The idea is that when you take your car and you have someone park it, you give them a valet key which has limited access to your car. It basically allows them to open the driver door and start the car, drive it, park it, and then hang it up. But if you have like a trunk, the trunk could not be opened with the valet key. So it's limiting the liability or the authorization of whoever has that key, the valet key. Now, does it make sense for me to always drive around with the valet key to limit my access? Well, you might say it does, but I don't think it does. I mean, you can interpret it however you want. Again, think for yourself. But I don't think it really makes a lot of sense. If you're the one always driving your car, do you really need to limit that? If you're always trying to do just about everything, what's the point? I almost always need to get it in the trunk of my car. And if not, I don't want to be caught off guard if I actually do. So when does OAuth make sense? Well, it makes sense if you need to hand out that valet key. And that typically happens when you're having third-party developers develop against your APIs. If it's only your company, then it probably doesn't make sense because it's like driving around with the valet key yourself. That said, it makes a lot of sense in many instances if you do have third-party developers. So one thing to point out, though, is a lot of people say, okay, well, I'm going to enter my username and password in the browser so that I can make sure that it's secure, right? I don't want to enter it into the application. And the thing is, if you do an installed application, at that point, if trust is broken, then you're already screwed because the third-party application could pop up something that looks like a browser and tell you to enter your credentials, and people will probably do it and then move on, especially if it's like a desktop app. Mobile apps are somewhat sandboxed, but in most instances, it's probably not going to save you. But what it can do is it can limit the liability of the people developing the app. So maybe they're actually trying to do the right thing, and they get compromised, and they're trying to do reports on your bank. On mybank.com, they're just doing reporting. And they get compromised, and they have an OAuth token, and the OAuth token is scoped to be read-only because they're just doing reporting on it. Well, that means that whoever's getting it can only read your information. That could be bad. Maybe they limit it so you can't do the account number either. Maybe there's a little bit more restriction on there, but they can't transfer the funds very readily, presuming you also can't read some of the transferring the account information. So it can be very helpful to people that are actually trying to do the right thing as well. So in general, you need sandboxing, and you need a reason to have that valet key. And typically that's if you're doing third-party applications. And if there is no sandboxing, the reason to do it isn't to protect the users from typing their password incorrect to the wrong person. It's about limiting the liability if something went wrong for an honest developer. And there are probably other scenarios. Actually, there are other scenarios, but this is kind of a general overall impression. And we don't want to spend a ton of time on OAuth because it's been covered quite a bit. But it does have its place. Every tool makes sense in some well, most tools have their place, I should say. So now we've identified who you are. Now we need to determine if you have access. So given I know who is trying to access a resource, you're authenticated, are you allowed to access it? And this is where authorization comes into play. In authorization, like many things in security, is best done in layers, right? And in Spring Security, you can do it in a number of ways, but the most prominent way is using the HTTP request to match on. So most of you said you'd seen the Java config, but this is basically saying that if the URL begins with public, then anyone is allowed to access it. If the URL, otherwise, if the URL begins with admin, only admin users can access it. Else, if it's any other request, you're authenticated. And I tried to word that rather carefully because as soon as you hit a rule, it's not going to continue down the chain. So that's one of the things that people oftentimes get confused with. So if you put any request at the top, none of the others are actually going to get invoked. And people are like, well, why don't you combine the rules? And I say, well, how would you do that? And they say, well, you do an or. You do an or on the rules, because that makes sense. And I say, OK. It might make sense if it starts with public. It's either permit all or authenticated. So permit all would win. OK, that makes sense. But what if it was admin? It starts with admin, but it also matches any request. So it's admin or authenticated. Oh, now we run into an issue. Well, I think it's an and. Well, we just covered the previous scenario. It's an or. So we can't really combine the rules. We basically have to let you define the rule and stop at the first one that's matched. There's no way to do that intelligently. All right, so if you do have an error in your URL-based security, it's nice to have an additional layer. You can do that pretty readily with Spring Security's method security. And in order to do this, you have to enable method security. We'll cover that in more detail in my talk tomorrow. But here's a nice way to define how to secure your methods. So return object is a keyword for the object being returned, in this instance, a message. And that message object has a property on it called to. That's who the message is to. And that's a user object. And that to object has an identifier on it. And so this is basically saying the identifier of who this is to on the left-hand side of the operation. And on the right, yes, please.
This doesn't help it from being called originally. This only verifies the return?
Yes, and we'll cover that in just a second. But very good question. I planted this guy in the audience, obviously, because he's asking exactly what I want to talk about. So thank you. I'll get you your $10 later. Not really. I don't have any money. OK, so anyways, the second part of the equation is the principal. The principal is the current user. And in this instance, the current user has an identifier property. So what is this saying? It's saying, is this to the current user? That makes sense. And some of you might be wondering about the question marks. That's basically a way of making sure that if the object is null, it terminates early. So if the object being returned was null, then the whole thing evaluates to null versus getting a null pointer exception. It's spell expressions. If you want to learn more details, you can look at Spring spell expressions. So this is pretty nice. It allows me to do this. And this makes sense because in this instance, my rule is based upon the information in the message. So it will happen after the method is invoked, but it won't get returned to the user. It'll happen afterwards, but it's OK that I do that lookup because I need that information anyways, right? So this is a post-authorize. Hopefully, does that answer your question? OK, great. And so there's also a pre-authorize. So a pre-authorize is before the method is invoked. And that makes sense when you're trying to persist something. So in this instance, I want to check to see if the message passed in, so referring to the object being passed in, we use a hashtag, if you're all hipster or a pound sign, whatever you want to call it, is how you refer to the message object. And then after that, you do the exact same thing. In this instance, we're doing it from the current user. So is it from the current user? You might have noticed something, though, about the first one. Now that we're talking about from, this message has a from and to property. But in the previous slide, we only talked about to. So yeah, we could combine this and say to or from that user. But that starts to get pretty verbose, and it's hard to test. So what we can do instead is we can use a has permission. So Spring Security has support for permissions. So in this instance, we're saying, do we have permission to read the object being returned? And you can do the same thing for, do I have write permission for the message being passed in? How do I implement that? Well, you can provide an interface, an implementation of permission evaluator. And let's break this down just a little bit. So let's see if my laser pointer is actually strong enough. Probably not. Oh, there it goes. So the first argument is authentication, right? So the authentication is implied. That's the current user, what the current user is. It's coming from the security context holder, get context, get authentication. We'll cover that in a little more depth in my next talk, but for now, the second argument, target domain object, is the first thing that you see in the spell expression. So if you look back here, in this instance, it's going to be the message. The message is the first thing being passed in, so that's the argument being passed in. So the target domain object will be the first thing that you see in this expression, and then permission is going to be read or write, so it's the second thing that you see passed in. And the reason why authentication isn't passed in explicitly is because it saves you some typing, so it's implied. All right, so that's kind of nice, but does that work if I'm trying to get lots of results, paged results? It doesn't, because you cannot, well, I guess you could, but you probably don't want to query all your results and then filter them out post-mortem. So a lot of people had to update their queries in order to actually access their objects as they wanted to. So in this instance, we're trying to get the inbox of the user. So the inbox is all the incoming mail, so it should be to them. And Spring Data provides a hook for Spring Security. Actually, Thomas is right here. He wrote this extension. He did all the work. I didn't actually do anything. So there's a hook, and Spring Security can provide principal.id. So that's, as we covered earlier in the annotations, that is referring to the current user's ID. So now we're querying for just the messages that are to the user. So that's kind of a nice hook. And you can get a lot more value out of it if you're trying to do paging. So you're like, oh, well, I had to write the query anyways, so what's the point? What am I getting out of this? Well, first of all, the query annotation is a lot easier than doing this directly, just defining this string. But furthermore, if you're doing paging and sorting, it provides even more value. So all I have to do is the same query annotation, and I'm getting all the results back that I want, and I have paging and sorting available for them as well. Of course, all the Spring Data features that you know and love are there. So at this point, I'm going to visit a little bit of In the Year 2000, Conan O'Brien reference. And I've referred to this slide actually way too many times that I'd like to admit, and had future work written up there as well. But we're actually making pretty good progress. So what is the idea behind this? Well, it is somewhat annoying to have to add the query annotation. So what if we could do this automatically? Spring Data is currently, we actually have a prototype. It's not where we want the code to be, but we have a prototype of where you can create a new domain object, say a message. And when you create that message object, it's going to automatically add read permission for that user. And so if I query for that domain object, whether it be a find all or a find by ID, it'll return to that user. But if I switch users and query for that same object, whether it be find all or find by ID, it no longer appears until you update the permissions on it. So it's automatically doing ACL queries for you. And there's still a ways to go. I wish I'd thought to write the JIRA number up here, but if you are interested, just Google for Spring Data Query Augmentation. I'll update the slides, and then you guys can access it that way. So there'll be a link to that query. So vote for that issue, or yell at myself or Ali on Twitter, and we'll definitely hear your thoughts. But we're already making pretty decent headway on that. So we're already getting fairly close to the end of the presentation. So in terms of wanting to have time for questions, so rather than doing a live demo, we're going to do the slide version of this demo. And so who here has heard of cross-site request forgery protection? Who here understands how it works and how to protect against it in detail? Less hands. All right, so we're going to go over it fairly quickly. Cross-site request forgery protection is an example of basically confused deputy problem is kind of what it is. But basically, if you log into your banking site and you leave that tab open or you just don't log out and you visit evil.com, and you go to evil.com and you see this giant button and you're like, well, what could go wrong on evil.com? Who here likes to win money? Anyone? Not very many hands. Everyone's rich. All right, that's fine. Okay. Well, I like to win money, so I'm going to click on that button. And what might happen? Well, the problem is that even though I'm on evil.com, if I'm submitting to another domain, in this instance it says localhost, but maybe it's mybank.com, but the idea is that they're separate domains. So the problem is that session in the cookie is going to be automatically submitted. It's automatically submitted even though I'm on another domain. And that means that as far as the browser and the server is concerned, it happened on mybank.com. So if I'm trying to, in this instance, delete a message from evil.com for this other application, it's still going to get deleted. You could also say maybe it's transferring money from one bank account to another. So there's a lot of things you could do with this type of exploit. So what happens? How do I protect against this exploit? Well, you could do it using a cross-site request forgery token. And what is the idea behind this? Well, the idea is that the cookie is going to be automatically included in the request. So if you're on evil.com, it doesn't have to know the value of it. It just submits the request and it's automatically populated. But with a cross-site request forgery token, it has to be manually populated. And since evil.com can't read the data on the other site, then it can't know the cross-site request forgery token. So you must manually provide that either in a token, in a header. Remember, sensitive information should be in a header or in the body of the request. So if it's a JSON request, you might do it as a header. If it's a form request, you might do it in the body. But Spring Security doesn't care as long as it's in one or the other. So I now get this question of, when do I use cross-site request forgery protection? And even if you already know what it is, this is a question that is good to ask yourself. And the answer is, as always, it depends. But the general answer that I can give is when your application is intended to be ran in a browser, even if it's also intended to be ran elsewhere, if it's intended to be ran in a browser, you should do that. And you say, well, my application uses JSON. So how are you going to forge those requests? Well, what if your form on the form on evil.com looks something like this? That means I'm going to produce valid JSON that looks like this. So I could post a message from evil.com to your site and produce a valid JSON message. So it doesn't matter if you're using JSON or not. And then I hear, but my application is stateless. And I say, well, HTTP basic is stateless, but the basic header is automatically included by the browser just like the cookie. So it doesn't matter necessarily if you're stateless. And then I hear, and I use custom header for authentication, and I ignore cookies. And I say, well, now you're getting a little ridiculous. But the problem is that if you're ignoring the cookies, you're probably not storing the session in the cookies, because if the person leaves the site and then comes back, they're not going to be authenticated. And that means that you basically opened another can of worms. So it's best to actually use the session, the cookies for your session, and provide a cross-site request forgery token. Now, how do I use cross-site request forgery protection? The answer is, first, to use proper HTTP verbs. And why is that? Well, we went over it. Sensitive information should not be in the URL. So if we're using a GET and we put a cross-site request forgery token in there, it could get leaked. So we don't want to do that. It's sensitive information. It should be in the body or the header of the request. What's more is, you don't want a person to have usability issues. If I hit the back button on my browser, I don't want to kill my application or my user experience, I guess. You don't want to have an error on there. If someone types a URL directly to your application, it's a GET. You don't want them to have to remember a GUID and type that out. Imagine if that was how you accessed your site. You'd have a lot of traffic. Yes, sir?
Does the CSRF change on every request, or is it throughout the session?
So the question is, does the token change on every request? And the answer is no. And the reason for that is because if I change it on every request, you kill your users, the usability of your user, because if they hit the back button, then they are going to have an invalid token. What's more is, if I'm an attacker, I'm not going to attack the token if it's changing on every request. I'm going to attack the session. The session doesn't change on every request, and that's how it's being associated to the user. So there's two reasons, usability, and I'm going to attack the least common denominator, which is the session. Does that answer your question? So there are strategies that do that, but my opinion is it's overkill for those reasons. And if you kill usability, then a lot of people just disable security. So then you're even less secure. So once you've used the proper HTTP methods, then Spring Security will say, for any post, put, or delete, you must include this token in the request, whether it be in the header or the body. And finally, you need to make, and that's done by configuring it. And that's done by default if you're using Spring Security 4.0+. If you're using Spring Security XML configuration prior to 4.0, we had to be passive, so you had to explicitly enable it prior to 4.0. Java config has been around the same amount of time as cross-site request forgery, so it's been enabled from the beginning. And then you need to include it. And how do you include it? Well, there's a number of ways. If you're using JSPs, Spring's JSP tag library will automatically add it to the form for you. If you're using Timeleaf, the same thing. GSPs also, it'll add it. What if you're doing a single-page application? You could create an endpoint that looks like this. And the parameter in there is the token that you need to know. Spring Security integrates with Spring MVC now. And it will provide that token for you. And then you return it in the response, and your JavaScript can request that endpoint and get the JSON token, or the cross-site request forgery token. I think we're going to go ahead and end there. There's just a little bit more, but we're gonna very quickly skip over this. And there's some related talks that I want to mention. So hands-on Spring Security 4.1 is going to be tomorrow at 8:30. I believe it's actually in this very room. And again, this is going to be more hands-on. So we talked about the theory behind why we're doing certain things. And tomorrow, it's going to be live coding and live exploits, seeing how we can exploit our application, and then how Spring Security helps protect against our application. And if you guys are worried, am I going to be bored if I attend both talks? Or if my friend might want to attend, is my friend going to be lost? And the answer is, there is a little bit of overlap, but you should not be bored because you attended this talk. Now, you might be bored because I'm a bad speaker, but you aren't going to be bored because you attended this talk. And what's more is your friend won't be lost if you invite your friend to come to the talk either. So it does have a little bit of review, but very minimal. And then I also wanted to mention real quick, if you want to learn about CORS support, which is new in Spring 4.2, I'm not going to cover that. So the reason for that is it's in the Spring MVC 4.2 new and noteworthy, and it's already going to be covered there. So don't expect that to be covered in my talk tomorrow, but feel free to attend that talk. I'm sure it will be very good. And there's a couple other pretty self-explanatory security-related talks there. So with that said, I'd like to thank you guys for your attention, and I hope to see you guys tomorrow, and I can open it up for questions.